This is Geometry, section 6.5, Conditions for Rectangles, Rhombuses, and Squares. So in the last section we learned what rectangles, rhombuses, and squares are. Now we're going to learn, if we are given a four-sided shape, how to tell if it is one of those three things. So how to show that a parallelogram is a rectangle. So if I give you a random parallelogram and it has certain markings on it, how do we know if it's a rectangle or not? One way would be to show that all four angles are 90 degrees, because we know that the four angles in a rectangle are 90 degrees. So if you can somehow show that that is true, then you have proven that it's a rectangle. Another way is to show that the diagonals are congruent to each other. That's another way that we would be able to say for certain that that thing is a rectangle. So in order to do this, we might need to use the distance formula. So just to write that out for probably the 6th time this year, x1 square root of x1 minus x2 squared plus y1 minus y2 squared. All right, for a rhombus, so three ways to show that something is a rhombus. One is we could show all four sides are congruent. So again, we might need the distance formula for that one. We could show that the diagonals are perpendicular, and for that we would need to know the slope. In order to show that two things are perpendicular, we need to know their slopes. So that would also apply to this one up here. In order to show 90-degree angles, we need to know slope. Another one is to show that the diagonals bisect the vertex angles, which is pretty difficult to show. We won't spend much time on that one. All right, so given this shape right here, it says that it is a parallelogram. We want to show that it's a rectangle. So let's first write out these coordinates that it gives us. So we've got 6, 14, 12, 6, 8, 3, and 2, 11. All right, so one way to show that this shape is a rectangle is to show that the diagonals are congruent, which is probably the shortest way to show it. We could also show that these are all 90-degree angles, but that would require us to find the slopes of all four of these things and then compare all four of them together. If we want to show the diagonals are congruent, we only have to find two things. So we will go that route. All right, so we need to find the length of the diagonals in order to say whether or not they're congruent. So we need, we need this one and this one. So first let's find the distance between B and N using the distance formula that we wrote down up above. We need the difference of the x-coordinates, so the x-coordinates of B and N are 6 and 8. And then we need the difference of the y-coordinates, 14 and 3. So 6 minus 8 is -2. When I square that, I get +4. 14 minus 3 is 11. When I square that, I get 121. When I add this together, I get square root of 125. And that does not come out evenly, so we'll just leave that like that for now. We'll see if we get the same thing for TU. TU. All right, set up the distance formula. T and U, the x-coordinates are 2 and 12, and the y-coordinates are 11 and 6. So 2 minus 12, 11 minus 6. 2 minus 12 is -10. When I square -10, I get +100. Plus 11 minus 6 is 5. When I square that, I get 25. 100 plus 25 is 125. So I also get the square root of 125 for this one. So we've shown that BN is congruent to TU. So since the diagonals are congruent, yes, this is a rectangle. All right, given these coordinates, show that GLAM is a rhombus. So easiest way, again, we want to do the least amount of steps possible. So the easiest way to show that something is a rhombus is to prove or to show that the diagonals are perpendicular, because then we just have to find the slope of this diagonal, the slope of this diagonal, and then see if they're perpendicular. So if they are perpendicular, these slopes should be opposite reciprocals of each other. That's how we tell if two lines are perpendicular. So slope is easy. We can just count it. So if I count from G to A, I'm going to count my rise and my run. So I'm counting up 1 over 1, 2, 3, 4, 5, 6, 7. So the slope of GA is going to be 1 over 7. Then I need to find the slope of LM. So if I count from L to M, now I'm counting down. So this is going to be a negative slope. So down 1, 2, 3, 4, 5, 6, 7, and over 1. So this is going to be negative 7 over 1, or just negative 7. These two things, the fraction flipped, and one's positive, one's negative. So these are opposite reciprocals of each other, which means GA is perpendicular to LM. So since the diagonals are perpendicular, that means that this is a rhombus. One of those properties of a rhombus that we learned yesterday. All right, can you conclude that the parallelogram is a rectangle, rhombus, or square, and explain why? So this one right here. We've got this piece is congruent to this piece is congruent to this piece. So this means that this diagonal is bisected and this diagonal is bisected. But we know that that's true about any parallelogram. In order for this to be a rectangle, which is what it looks like it might be, we would need to know that all 4 of these pieces are congruent to each other. Because in a rectangle, the diagonals themselves, this whole piece and this whole piece, are congruent to each other, and they bisect each other, so all 4 pieces end up being congruent. But since we only had this piece congruent to this piece and this piece congruent to this piece, this would not work. So this would not work because this is true for any parallelogram. All right, this one, we've got a right angle in the middle, which is an indication that this is a rhombus. Anytime you've got your diagonals perpendicular to each other, diagonals perpendicular, therefore, remember the 3 dots means therefore, so therefore this is a rhombus. Okay, this one, this means that these 2 angles that are cut by this diagonal are congruent to each other, or they are, this whole angle is bisected. So this is also a rhombus, because that is true for a rhombus. The diagonal bisects the vertex angle. Okay. This example here, we are given the perimeter of the rhombus is 100 centimeters. So all the way around here, these 4 sides add up to 100. For a rhombus, we know that all 4 of these sides are congruent to each other. So if I've got 4 sides and they all add up to 100, to find what each one is, I would just divide 100 by 4. And I would get 25. So I know each of these pieces is 25. So to solve for x and y, all we do is 4x equals 25, 2y equals 25. And then here we would divide by 4. Here we would divide by 2. And those don't come out evenly, so we'll just leave them as fractions. X equals 25 over 4. And y equals 25 over 2. Z, right here, we know that since this is a rhombus, it tells us it's a rhombus. We know that the diagonals are perpendicular, so this has to be a 90-degree angle in the middle here. So if 3z equals 90, when I divide by 3, I get that z is 30. All right, all of the following are parallelograms. Explain why they must be rhombuses. So we know that it's a parallelogram. So if I know this is a parallelogram, then this side right here is 20, means this side across from it also has to be 20, because in a parallelogram, opposite sides are congruent. This side is 20, means this side is 20. So now I've got all 4 sides are the exact same. So this has to be a rhombus. So all 4 sides are congruent. Over here, we've got the diagonals drawn in. So to find this angle in the middle, which should be 90 degrees if this is a rhombus, because it needs to be perpendicular if this is a rhombus. So we would add up 43 and 47, which we already have. When we do that, we get 90 degrees. So if I take these two added together and subtract it from 180, 180 minus 90 is also 90, which means this has to be a right angle right here. So since the diagonals are perpendicular, that's why this one is a rhombus. This one is similar to the letter C that we did up above. Since these are marked congruent, that means the diagonal is bisecting the vertex angles. Diagonal bisects vertex angles. Because since this is a parallelogram, that means this triangle is congruent to this triangle. So this angle would have to be the same as this angle. And then since these two are congruent to each other and opposite angles are congruent, this angle has to also be congruent to this angle. The same would be true for these other four angles over here. So our diagonals are bisecting the vertex angles, so that's why this one is a rhombus.